How is it going, ladies and gentlemen? This is the Wolf Around, and it's great to see you here. In today's video, we are diving into this secret C++ development environment for Linux. After watching this video, you'll feel confident about compiling large open source projects written in C or C++. Whether you are a beginner or an experienced developer, having a robust and efficient C++ development environment on Linux is key to fast builds and smooth development. In my previous video, I showed you how to set it up on Windows, and today it's all about Linux. Let's get started. To run your C++ code, first you need to be able to compile it to the machine code. In order to do that, you need to install a C++ compiler. On Linux, the most popular choice is GCC. It's open source, widely used, and can handle large C++ projects. CMake is a build system generator. So, what is a build system generator? Think of CMake as a project manager. It helps organize all your files and tells your build system how to put everything together. Simply I say, CMake generates the scripts which will be used by the build systems like Make or Ninja. These scripts contains information about the source files, header files, and third parties of your C++ project. A build system can work differently in different operating systems. CMake helps you to configure cross-platform C++ projects, whether you are developing on Windows, Linux, or macOS. CMake generates the necessary build scripts for each platform, allowing you to focus on coding rather than configuring. The Make build system is a widely used tool in software development for managing and automating the build process of projects, especially those written in C++. Its purpose is to streamline the process of compiling code, managing dependencies, and linking files, ensuring that only the necessary parts of a project are revealed when changes are made. The Ninja build system is a fast, minimalist alternative to traditional build systems like Make. It is designed to handle large, complex builds with a focus on speed and efficiency. Alright then, let's start setting up our C++ development environment. Let's open a terminal and install everything we need with a single command. One of the advantages of Linux is how package management simplifies setting up tools. We have installed everything we need all at once. We have installed C++ compiler, C++ debugger, Make build system, CMake, and Ninja build system at the same time. Now we can start creating our Hello World project using CMake. We won't use any code editor or IDE while doing this, because you should be able to compile your code without using any code editor or IDE as a software engineer or a good programmer. While IDEs are convenient, it's crucial to understand how to compile code manually. This ensures you can work in any environment, whether it's a server, a lightweight virtual machine, or even for automation scripts. Now I'm going to create main CPP and CMakeLists.txt files. Main CPP is going to contain Hello World code. Let's write the Hello World code quickly. CMakeLists.txt file is going to contain our Hello World project's CMake configuration. I'm going to write most basic CMake configuration for a Hello World project. but I'm going to explain each line briefly. First, I'm defining minimum CMake version. It means this project cannot be used with lower version of CMake that I defined in this line. And then I'm giving this project a name. And lastly, we are going to add our source files to this CMake project. Since we are going to create an executable, we are going to use add executable command of CMake. First line of this command is project name, and the following lines are consist of source files. In our case, there is only one source file, which is main CPP. Now, our CMake configuration is complete. We can start generating our build system files using CMake. Terminal should be opened in the same directory as CMakeLists.txt. Let's run CMake with some arguments that is going to be helpful for the build system we are going to use to compile this project. The G argument is for generator, which means if you type Unix makefiles, CMake is going to create the build system files that is going to compatible with Make. You can omit it because its default value is Unix makefiles, and the B argument is for you to define generated project files output directory. Okay, let's generate Ninja build system files too. When you need to generate your build system files with Ninja, you have to explicitly write its name, and don't forget to write generated project files output directory. Let's compile them one by one. First, makefiles. We are going to type a simple CMake command. The first argument of this command is generated project directory, and the second argument of this command is build type. When building a project, you can compile it in different configurations. For example, release means it's optimized for performance and ready for distribution, while debug is meant for troubleshooting and allows you to step through the code line by line. Here, we are telling CMake to compile the project in release mode. You can compile this project in release or debug. I'm going to compile it in release. We saw the output, everything as we expected. Now it's time to compile with Ninja. Okay, compilation is complete. Let's run the executable and see the result. Great, everything as we expected. Alright, we have come to the end of first section of this video. Now let's move forward and install some code writing environments like VSCode and CLion. Let's download VSCode. Download is complete. Let's install VSCode. Launch the VSCode and go to the Extensions tab. Install C++ Extensions pack. When the extension has installed, open our project in VSCode. C++ extension detect our GCC installation. Select it. The CMake tools extension of VS Code started to generate build system files. It is going to create a folder named as build as generation output directory and use Ninja as generator type since we install it at the beginning of this video. It has generated Ninja build system files. Let's learn how to change it from settings of CMake tools. Type here Unix makefiles. And lastly, let's change build director name. Press Ctrl+Shift+P and type CMake configure. Hit enter and generate this project with Unix makefiles. Now press F7 from your keyboard or click the arrow button from bottom left side of the VS Code window to build and run. Now let's test our debugging tools by putting a breakpoint. Run the application by clicking Insect button and wait for the debugger catch the breakpoint. Press Ctrl+Shift+P and type CMake select variant. Hit enter and choose release. Run again and VS Code utilization is complete. Let's download CLion. Download is complete. Let's install CLion. Open archive. Extract its content to home directory. Go to bin folder in it. Run the command sh clion.sh. Open our Hello World project in CLion. CLion detected our C++ development installation. Now I'm going to show how to configure CLion's CMake profiles quickly. Ninja is default generator type already. I'm setting build directory. And now let's create a build profile for release. Let's compile our code. Let's switch between profiles. And that's it. Now you are equipped with everything you need to tackle C++ development efficiently on Linux. Whether it's speed, simplicity, or flexibility, this environment is designed to make your coding experience smooth and productive. In my previous video, I showed you how to set up best C++ development environment on Windows. You can check that video too. If you found this video helpful, please hit the like button. And for more tutorials on C++ programming, game development, and more, don't forget to subscribe and join the pack. See you in the next one.